Okay, welcome to the video for objective 1B through 1D. You can see them all right here. I can convert a fraction to a decimal. I can convert a decimal to a fraction. And you don't need to write this down right away. You're going to see it on each slide. Write it down at that point. And I can place real numbers, numbers. And real numbers include fractions and decimals and whole numbers on the number line. And this means that you have accurate spacing, stacking equivalent numbers, and placing decimals and fractions correctly between whole numbers. Okay, so let's go ahead and start with this first objective here. I can convert a fraction to a decimal, and so you're going to want to start writing this down here. So all you need to do this is divide the numerator by the denominator. So first thing, which is the numerator, which is the denominator? This is the numerator, and this is the denominator. So we're going to take 3 and divide it by 4, and go ahead and put 4 into 30 now. So 4 into 30 is going to go 7 times. 7 times 4, 28. Subtract that. We get 2, bring down our 0. 4 into 20 goes 5 times. So our decimal for this first problem here is 0.75. Okay, and you might have already known that, but I want to show you the long way of figuring it out as well. Let's go ahead and try another one together. Okay, so we're going to go ahead and put 6 into 5. Put 5 under here. Oops, I'm still getting used to writing with this. Divide by 6. And let's put a couple zeros over here. That is almost illegible. All right, put the decimal point up here. And now, how many times does 6 go into 50 without going over? Well, if I put it in 8 times, 6 times 8 is 48. If I put it in 9 times, 6 times 9 is 54. So that's going to be too much. So let's just go ahead and put it in 8 times. So 6 times 8, 48. Subtract here. 20. Now we need to think of how many times 6 is going to go into 20. Well, 6 times 3 is 18. So 6 times 3, 18. Subtract. We get 2. And as we keep going with this, we're going to see how it's just going to repeat. Again with 3. So you can just go ahead and put a bar over 3, or back here you could have already determined that it's repeating, so you can go ahead and put a bar over this 3. I am horribly sorry about my messy handwriting. I will get better at this. Okay, so we did 5 over 6. Now let's do 6 over 5. And hopefully you see that it's going to go in at least once. So when we go ahead and do that, let's take our 6 and divide by 5. And it does go in there once. And then we multiply times 5, minus it, and we get 1. So we want to keep going. So we're going to go point and put a 0 here, put a point here. Well, how many times, if I bring down this 0, does 5 go into 10? It goes 2 times. So our answer on this one, 6 over 5, is the same as 1.2. Okay, let's look at our next objective here, objective 1C. I can convert a decimal to a fraction. So we're going to start by making a fraction, and let's go ahead and get a number out here to work with. So we're going to follow these steps here, but we're going to work with this 0.5 and find out what it is. You probably already know what 0.5 is, but let's go ahead and follow the steps to see how to figure this out if you have a number that you don't know. Okay, so you're going to put the number without the decimal on the top. So we're making a fraction. So let's go ahead down here and make a little bar. There we go. Put the number without the decimal on top, so we're going to put our 5 on top. And then I'm asking you to decide what place does the original number end in, and then put that number on the bottom. So let me show you what I mean by that. And you don't need to copy this whole chart, but my number here, my original number, ends one spot after the decimal, right? So that's the 10th place. So what that means is I'm going to put a 10 on the bottom of my fraction. So let's go ahead and put a 10 on the bottom of my fraction. Another way to think of this, and I'm going to get rid of my little chart here, or instead of thinking about this over here, you can think about counting the number of places after the decimal and putting a 10, 100, 1,000, 10,000, etc. with the same number of zeros. So I have one decimal place after the decimal. So that means I'm going to put 1 0 down here with a 1 in front of it. And I'll show you again with another problem. And then the last step here is to reduce. So what number goes into both the top and the bottom? Well, 5 goes into both the top and the bottom. 5 goes into the top 1 times and into the bottom 2 times. And that's why 0.5 is the same as 1/2. Okay, so let's try a different number now. Now I have 0.125. We're going to follow the same steps as we did on the last one. I'm going to go ahead and make my fraction bar. I'm going to put the number without the decimal on top, so I'm going to put 125 on the top. And then you need to know what place this 5 is in. So either you know your places, and that is the thousandths place, or you can just count up the number of spots after the decimal you have. So let's count them up. We have 1, 2, 3. That means I'm going to put 1, 2, 3 zeros down here and then put a 1 in front of it. I kind of think that's the easier way of thinking of it, unless, of course, you know all your places and you can just look at it and say, oh, I know that that's in the 1,000 spots. I'll put 1,000 there. Whichever is easier. Okay, so last step here, we need to reduce. Well, because I see there's a 0 here and there's a 5 here, I know that 5 is going to go into the top and bottom. You might want to see if you can think of a bigger number that goes in the top and bottom, but if you can't think of the biggest number, you can always just go with 5. I can also tell that 25 is going to go into the top and bottom. So since I saw that 25 is going to go in, I'm going to go ahead and use 25. But if you started with 5, that would be fine. Also, you would just have to spend more time reducing. Okay, so 5 goes into the top. 25 goes in the top 5 times, and 25 goes into the bottom 40 times. Now, is this fully reduced here? Is there anything that can go into the top and the bottom? There is. 5 can go into both the top and the bottom. 5 is going to go into the top 1 time and into the bottom 8 times. So there we go. 0.125 in fraction form is 1/8. Okay, let's try one more. Now we have a number to the left of the decimal point, but we're still going to follow these steps here. So let's go ahead and write 1, 6 at the top. And then how many spaces do I have, or how many numbers do I have after the decimal point? I have 1 number, so that means I'm going to put 1 0, just like that. And then it's just a matter of reducing. So what goes into both the top and the bottom? Well, they're both even numbers, so I'm going to go ahead and put 2 into the top. It goes 8 times. Into the bottom, it goes 5 times. This is perfectly fine, just like this. But if you want to change it into a mixed number, you would see how many times 5 goes into 8, and that's 1 time. And then subtract 5 from 8, and we get 3/5. So either of these answers is fine. Okay, our next objective, I can place real numbers, and this includes fractions and decimals, in order on the number line. And the important thing here is that you have accurate spacing, that you stack equivalent numbers, and that you place decimals and fractions correctly between the whole numbers. So let's go ahead and put a few numbers in here. Okay, let's start with 0, right there in the middle. And now let's throw some numbers to the right and to the left here. And we want accurate spacing. So if we're saying that this is 1, then about the same distance away that 0 is from 1, 1 should be from 2. Okay, so for instance, I'm going to draw my 3 here. We don't want to put the 3 then here and then the 4 over here. We want to keep them all pretty much close together, or I'm sorry, the same distance away. Back up here, add a few more in here. Oops. 3. And when we head the other direction, we still want the same spacing over here. So -1, -2, and so forth. Now let's say we want to put some fractions in here. You want to think about how close the fraction should be to either side here. So for instance, if I wanted to put in -1/2, it should be right here in the middle. If I wanted to put in 1 3/4, it should be closer to the 2. So if you can picture, this is about halfway. 3/4 is going to be about here. So 1 3/4. Okay, and then it says stacking equivalent numbers. So let's say I needed to put 0.5 or -0.5 on this number line, and I needed to put in 1.75. What that means is any number that should occupy the same spot on the number line, so right here, I would stack them. So if I have this number above, if I have -1/2, would go right underneath it. So -0.5. And here I'm showing 1 3/4, which in decimal form would be this. So that means I'd have to put it right above it. So that's what we mean by stacking equivalent numbers. Okay, so let's just go through this objective, make sure I showed you everything. Accurate spacing, we talked about that. Placing decimals and fractions correctly between whole numbers, we talked about that. And stacking equivalent numbers, we talked about that. All right, that's it. Please make sure that you write down any questions you have for me, and I will answer them in class.